Hi, this is Mrs. Yamamoto, and today we're going to talk about properties of exponents. The first thing we're going to talk about is a base, an exponent, and a power. So let's look at an example. Let's say I have the number 2. 2 is considered my base, and let's say I have an exponent of 4. So I have 2 to the 4th power, and I know that that's equal to 2 times 2 times 2 times 2. And my exponent of 4 indicates that I have 4 factors. So the product of repeated factors can be expressed as a power, that is using an exponent and a base. Let's break down multiplying powers in a guided exploration. We're going to start with the original form, we're going to factor it out, and then we're going to simplify. So for our first example, 5 squared factored out and 5 cubed factored out. In simplified form, this gives me 5 to the 5th power. Notice I have 1, 2, 3, 4, 5 fives. X cubed times x to the 7th. If I factor this out, that's x times x times x multiplied by x to the 7th power, so there's 7 x's. 6 and 7. That gives me x to the, so how many do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So x to the 10th power. In my last example, I have x squared, y to the 4th, multiplied by x to the 4th times y. And remember that if your base does not have an exponent visible, the exponent is 1. So this is times y. So I'm going to go ahead and count up. I have 1, 2, 3, 4, 5, 6 x's. So x to the 6th power. And then I have 1, 2, 3, 4, 5 y. So y to the 5th power. Based on our guided exploration, we can go ahead and draw a conclusion here. There is a multiplying powers rule. To multiply powers with the same base, we're going to keep the base the same. So let's say our base is a, and we're going to add the exponents. Let's say we have an exponent of m and n. We're going to add those exponents. So in our first example, our base of 3 stays the same, and our exponents, we add those. So we get 3 to the 5th power. In our second example, we keep our base the same, x, and we add our exponents, 5 plus negative 3. This gives us x to the 2nd power. So moving on now to dividing powers in a guided exploration. We're going to again go from original form to factored form and simplified form. So 3 to the 6th power. When we factor that out, we get 3 times 3 times 3 times 3 times 3 times 3 divided by 3 to the 3rd power. We simplify this in factored form, and we're left with 3 times 3 times 3 divided by 1. So in simplified form, we can say that this is 3 to the 3rd power over 1. Or we can say 3 to the 3rd power, or 3 cubed. In the next example, we're looking at x squared divided by x to the 7th power. So factoring that out, I get x times x. And then on the bottom, I have 7 x's. When I simplify what's in factored form, I'm left with 1, 2, 3, 4, 5 x's. But what's on the top? On the top we have 1. The 2 x's canceled out, and as our denominator we have 1, 2, 3, 4, 5 x's, so x to the 5th. In our third example, let's go ahead and factor out x to the 5th and y to the 2nd, y times y. On the bottom we have x to the 2nd power, so 2 x's and 6 y's. If we simplify our factored form, what do we have left here? So we have 1, 2, 3 x's, so x to the 3rd power, divided by, and 1, 2, 3, 4 y's, so y to the 4th power. Down below here we have a dividing powers rule. When we divide powers with the same base, we keep the base the same. So let's say we have a base of a, and we subtract the exponents. So to divide powers with the same base, we subtract their exponents. In the first example, you'll see that we have 2 to the 7th power divided by 2 to the 3rd power. So breaking this down, we keep the same base of 2, subtract the exponents, so we're left with 2 to the 4th power. And in our second example, we're going to follow the same rule, and we're going to keep the base the same, and we're going to subtract our exponents. So what we find is we get x to the negative 4th power. Notice now we have a negative exponent rule we're going to talk about. That's going to apply to example 2. So when you have negative exponents, it's important to keep in mind that negative exponents indicate reciprocation, or a simple way to refer to that is that you flip and make the exponent positive. So in our first example, x to the negative 3rd power is the same as x to the negative 3rd power over 1. So if I flip and make the exponent positive, it's basically taking that entire portion and moving it to the other side. So what's now going to be on top is the 1, and on the bottom I'm going to have x to the 3rd power, and it's now positive. Looking at a second example, again, if I flip and make the exponent positive, we now have x to the 5th power on the top and 1 on the bottom, which is the same as x to the 5th power. So going back to example 2, remember we have x to the negative 4th power. So if I want to simplify that, x to the negative 4th power over 1, I'll flip and make the exponent positive, so we end up with x to the 4th power on the bottom and 1 on the top, and that's our answer. Now let's look at some more examples on multiplying powers with the same base. Remember that to multiply powers with the same base, we keep the base the same and we add the exponents. And there are 3 steps. First, we're going to group the like terms, then we're going to multiply the coefficients, and then we're going to add the exponents. So in our first example, let's go ahead and group our like terms. So we have x to the fourth, and x to the third, and y to the third, and y to the seventh. So I'm going to go ahead and regroup those like terms. So x to the fourth times x to the third multiplied by y to the third times y to the seventh. So in this case, my coefficient is just 1. So we're just going to move on to the next step and add the exponents. So in our first set of like terms, we're going to get x to the seventh power because we're adding the exponents, and y to the 10th power. So remember, when you have the same base, we add these exponents. Multiplying powers with the same base, we add the exponents. In example 2, we're going to go ahead and group the like terms again. So 4 and 2, those are our coefficients. Our like terms are x to the fifth and x, and then y to the second and y to the sixth. So those are our like terms. So when I regroup these, I'll have 4 times 2, and then I can regroup my x values, so x to the fifth and x, and then y to the second and y to the sixth. So I'm going to multiply my coefficients, and I'm going to get 8. My like terms, x to the fifth times x. Here I have an exponent of 1, so I'm going to add those. That gives me x to the sixth power. And then lastly I have, again, the same base, so I'm going to add the exponents. So I now have y to the 8th power. So I'm going to box my answer and move on. Next we have dividing powers at the same base. So remember, keep in mind when you divide powers at the same base, you keep the base the same, but we subtract the exponents. So in our first example, I want to start by separating and grouping the like terms. Then I'm going to divide the coefficients and then subtract the exponents. So first thing I'm going to do is separate and group the like terms. So my like terms in this case are x to the sixth and x to the fourth. So if I regroup those, x to the sixth divided by x to the fourth, and then I'm going to multiply that by my other set of like terms, y to the ninth power and y to the fifth power. Now I'm ready to divide the coefficients. Remember, when I divide the coefficients, I subtract. So if I subtract 6 and 4, I get 2. And when I subtract 9 and 5, I get 4. So this is our final answer. In example 2, let's go ahead and follow the same steps, and we're going to start by grouping our like terms. 18 and 3, 8 x to the 8th power divided by x. Remember that if you don't see an exponent, the exponent is 1. And finally, our last set of like terms. So now I'm going to go ahead and divide the coefficients. And I'm going to get 6. 8 minus 1 is 7. And 10 minus 4 is 6. So I have my final answer. In our last example, we're going to talk about negative exponents. Before we go over the examples, I do need to apologize. There is one mistake on your example. On example 1, there should be an exponent of 8 next to that y there. So please add the exponent of 8 to the example. So that's already there. All right, let's go back and look at our steps to solving this. So remember that negative exponents indicate reciprocation. And one way to look at this besides flipping is that you are changing levels. So what did I write? I wrote a 1 underneath that expression for example 1 because in that expression it does have a numerator and a denominator. And the denominator in this case is 1. The numerator is one level, the denominator is another level. So when we want to make our exponents positive, we change their level. So y to the negative third power will change levels, and x to the negative second power will also change levels. What's left on the top? X to the 6th. That's left over, and y to the 8th is still up there. What's now on the bottom? 1 times y to the 3rd and x to the 2nd. So I'm almost done. Now I just have to use multiplying and dividing powers rules to simplify. So if I want to rewrite this, I can rewrite it as x to the 6th times y to the 8th. And I'm just going to make my life easier here and put x to the 2nd underneath the x to the 6th and y to the 3rd there. And we know that there is a coefficient of 1, but we do not have to write the 1. So now that I'm ready to simplify, I remember that my dividing powers rule tells me that if I have the same base, I subtract the exponents, right? So if I have the same base, I subtract the exponents. So let's look at what we have here. I have a base of x, so I'm going to go ahead and subtract the exponents 6 and 2, so that gives me x to the 4th power. And I have the same base of y, so I'm going to subtract those exponents and get y to the 5th power. And there's my answer. And our last example. Again, remember the idea that we are changing the level. So all I have to simply do is look at what my terms are that are going to change levels here. Y to the negative 9th power is going to move to the bottom, and x to the 3rd power is going to move to the top. So what does that look like? Now I have x to the 3rd power on the top. I have x to the 8th power, z to the 3rd. Those are still there. But what's now on the bottom? That y to the 5th is still on the bottom, and then that y to the 9th power moved to the bottom. It changed levels. So now that I'm ready to simplify, I can remember that I have a multiplying powers rule. So what do I notice? I notice that I have x to the 3rd and x to the 8th. So multiplying powers rule, what do? I add the exponents when the base is the same. So this will give me x to the 11th power, and I still have my z to the 3rd, divided by, and again here on the bottom I have the same base, so I'm going to get y to the 14th power. And I'm done. Thanks for watching. This is Mrs. Yamamoto. And remember, in math and in life, remember to strive for progress, not perfection. Have a great day.